Hello, nice to meet you. We are attending class of CS580, graduate level computer graphics. I'm Sung Yoon, the main instructor of this course. In this course, we will talk about the computer graphics, but we will mainly focus on the rendering. Before we talk about our class topic, I'd like to introduce myself to you. I joined the KAIST 2007. Also, I've mainly working on in the field of computer graphics. I got some of the award and here and there. My main research mainly focusing on the computer graphics, especially the rendering and robotics, and also the computer vision problem that are also related to the computer graphics. Before, I'm mainly working on the rendering massive geometric data like the Boeing 777 model, something like that. But in this day, I'm mainly working on the designing scalable graphics and geometric techniques to efficiently handle massive models under this common hardware. Mainly, I'm working on working on photorealistic rendering in the field of computer graphics, image search for computer vision, also the motion planning for robotics. I'm based on my prior experiences on these fields. I will actually talk about our lecture material. Fortunately, I got some recognition on my research topics, including the rendering. I got a Test of Time award at the year of 2015 on the field of rendering. Also, I produced a few professors, including the field of rendering. Also, I had many research collaboration with domestic and international companies in the field of computer graphics. Here are my contact information. You can write down questions through KLMS. Also, you can send some email to my email address. Also, this slide including shows my physical office. Also, my homepage. This is our class time in this semester. We will have the offline. We will mainly have the offline class from the 2:30 to 3:45 on Monday, Wednesday. But since we actually have many Omicron this time, I will actually have I will have the video lecture, but later on we will have the offline class. Since the offline class the main class type, we will have in this semester. Also, you can write down the any questions through the KLMS. Also, if you want to have the physical Q&A, you can ask any question right after class. Here we have our TA information. We have the one TA this semester, Jaeun Kim, and you can see his email of the physical office location. But it is recommended for you to share question on KLMS first before sending emails to directly to TA. In this class, we will mainly discuss various parts of computer graphics, especially on the interactive rendering. As you can see, computer graphics consists of mainly three parts: modeling, simulation, rendering, and imaging. Once we set up some of the model, like the 3D meshes or some of the appearance model of the 3D model, then we perform the rendering techniques, something like the ray tracing, which is also we can call the simulation. Then in the end, we can get the image as shown on the right side. And there are some of the related techniques fields like computer vision. Computer vision simply the invert this process. In other words, starts from the 2D image, and then it tries to understand also extract the 3D model or something like that. Image processing deals with the image, and also some of the recent techniques like the robotics and AR, augmented reality, combine real and virtual world on the modeling or the image spaces. As you can see, there are lots of the application of computer graphics. You know that the 2D games, some of you may know that this game. And as you can see, the game industry is one of the biggest IT sector in Korea. And also there are many these movies and film special effects. And here are some of it's kind of old one, but actually these are some of the well-known the movie that made out of lots of the computer graphics techniques. Also this Avatar 3D movie. Also, the computer graphics also used a lot for the computer aided design for building some of the large scale, the man-made ships and some other objects. Also, we use the computer graphics for the medical applications. Out of this 2D image, we build a 3D model, and then we can also visualize it, something like we can also do this volume rendering to see the internal structure of some of the objects. And also, recently we got the AR technique, augmented reality, becomes AR, also VR, virtual reality becomes very popular. So there are one of this recent popularity of the AR VR actually comes from the HMD device, head-mounted display. This also showing the HoloLens made by the Microsoft for augmented reality. In these days, also the generating realistic sound is also important, like the generating these realistic images. Also, the generating realistic sounds. Some of its technique for generating realistic sound actually are very similar to this generating realistic images. So also for example, we can use the ray tracing technique for generating sound. For example, here we can use the generated sound here.
Hello, anybody here? Hello, anybody here?
You can see the some of echo once we are inside the building, something like that. Also, we can utilize some of the rendering techniques for even the localized sound for the robotics applications. I'm not going to talk about the details about this application, but main point is that the rendering techniques actually some of each algorithm can be used for the many other related applications. So in this course, we will mainly focus on the following things. We will mainly focus on the studying on the basic concepts of the physically based rendering, and then we will also talk about some of the recent techniques and discuss their pros and cons. Photorealistic rendering is actually achieved by simulating light and material interactions. So in this class, we will mainly talk about how we can simulate the light and material interactions. And this simulation governed by the rendering equation. We will talk about this rendering equation as one of the main topics of this course. And there are many terms are used for generating these realistic images. One of the such terms is actually known as this global illumination. Global illumination algorithm solves the rendering equation. Basically, it generates 2D image out of these 3D scenes. 3D scenes actually it actually has some of the emission information about the light sources of the geometry, about that describe the object shapes and BRDF, which represent this appearance model. And then global illumination over this physically based render technique can generate these kinds of realistic rendered image. There are actually early on the ray tracing and also radiosity has been known as some of the basic technique for generating generating realistic images as this global illumination. So we'll talk about this ray tracing and radiosity, but some of the recent techniques actually based on the Monte Carlo ray tracing technique. So we will move on to the Monte Carlo techniques. Classic ray tracing technique actually assumes perfect specular or diffuse material, something like this. And then based on that assumption, we can generate this kind of realistic shadow and transparent object and so on. But it's generating lots of ray, which takes a lot of time. On the other hand, classic radiosity assumed the diffuse interreflection and then was able to generate this kind of realistic techniques. But actually, this classic ray tracing and classic radiosity has their pros and cons. And recent techniques actually they're actually based on this kind of the ray tracing and radiosity, but they are extended to handle more realistic materials, more than just having the ideal or perfect specular and diffuse materials. And then one of the main techniques that Monte Carlo ray tracing, which we will talk about later on. Also, there are many other related applications, the generating sound or AR, VR application. if you're interested, you can go over some of the recent paper along those applications based on the. But basically, there are lots of techniques about AR VR technique. But I wish that you can actually find some of techniques that are based on the lecture material that we talked about in the class, like the ray tracing, something like that. And also the AR for the realistic AR technique, we need to estimate the light. But thanks to the recent deep learning technique, we can also estimate even light source out of the input image. This input image are really complicated, but the main idea is that we can actually estimate light sources. And then once we estimate light sources, then we can perform the ray tracing, and then we can generate a realistic image. These are some of the topic lists that we'll talk about in this class. But in this class, we'll mainly talk about the path tracing, which is nothing but Monte Carlo ray tracing, and rendering equation, and some other Monte Carlo technique. And then we'll move on to some of the recent techniques based on deep learning. These are the prerequisites for the course. We assume you had a basic programming skills and had a basic understanding on the data structure and linear algebra. Also, we assume you know the basic deep learning knowledge and programming skills. So in this class, one of the main activity is that you need to implement some of the prior techniques. So that's why actually we had this kind of the prerequisite. If you're unclear, I recommend you to express your concern and opinion through the KLMS. Here are some of resources that you can utilize. I spend in the lecture material. Sometimes I cannot talk about all the low-level details, but that's why I prepared the textbook for topic rendering. I spent lots of time for preparing this textbook. So if you're unclear some of topic, then I recommend you to go over this rendering book. This one. Also, you can access the textbook through this link. Also, there are many other books. Also, you can find those books from the library. But I prepared my rendering book so that you don't need to go over some other related references. And also, there are many technical papers available. CGraph Asia is one of the two main top conferences in computer graphics. Also, there are many related top-tier conferences like ISMA about the AR technique, CVPL, ICCV, computer vision, ICRA-IROS for the robotics applications. In this course, I will give the lecture about the lecture materials before the midterm exam. After that, basically, each student need to present some of the papers that are related to our lecture materials. So basically, half of lecture will be given by me. On another half of after the midterm exam, basically we will have the student presentations, and there will be some of midterm and final term exams with a few quiz, and also there will be a few problem assignments. And then as a student presentation, you need to present one or two. You need to present some of the papers, and there will be team project and some of the project presentations. For the paper presentation and final team projects, basically you need to make a team. You need to make a team of 2 or 3 members. So basically, once we know the exact count of once we know the exact count of students who are attending who are taking this course, we can let you know how many people you can make a team for each team. And once you have a team, you need to choose a topic for the team, and each team member present a paper that are related to that team topic. And also, all the team members implement the techniques of the sum of paper, and then our main goal is that I wish that you can implement some of techniques and improve some of component of those recent techniques. And along that line, role of each team member should be very clear. And then you need to present what the team did for the team project. And then also to encourage you and each member of team member, we will choose the best speaker for the paper presentation, also this best project, team project. And then I hope that before we have the COVID-19, we actually had a lunch or dinner further already with me and TA. But I also wish that we can also have that kind of activity later on in this semester. And once we are chosen as the best speaker or the best team project, a high grade will be given to the members of the best project team member. These are the grading, and 40% for the quiz, assignment, exams, and 30% for the class presentation, another 30% for the final project. So basically, in this course, this is actually research-oriented the course, so that paper presentation, in other words, class presentation, and final project presentation is actually one of the other two main activity for the course. And also, basically, once we actually set up the deadline for the assignment or presentation, you need to do the before the deadline. In other words, no score for the late submission. So submit your work before the deadline, and then instruct TA, and the student will evaluate presentation and project. In other words, basically the TA and TA or me will give the 50% of the weight for their evaluation, and then all the also the fellow students who are taking this course will give the 50% of weight. So basically, you don't need to prepare your presentation for instructor or TA. Basically, just prepare your presentation for other students. So that way, students who are taking this class can learn something from you and your presentation, which is the main goal of this course. This is our class attendance rule. If you're late 2 times, we will count as 1 absence, and for every 2 absence, we have to lower your grade 1 level. For example, if you got an A- without having this class attendance rule, but if you're late, if you're absent 2 times, then we have to lower from A- to B+. So also to check your attendance, we will call your names or also take pictures. If you are in some situation where you should be late, you should notify to me or the TA through KMS earlier. Our official language in this class is English. I will give you a lecture in English, but sometimes I might have to use the Korean if there are some more materials unclear to you. Then even at that case, I will summarize the content that are given in Korean into the English. Also, you are also recommend to use the English for question, but it's not recommend. It's not required. If you ask the question in Korean, that's fine. But at the end of having the Q&A in Korean, we will actually summarize them in the English. And this schedule, and then some of the lecture material will be available at the KLMS site. Also, they will be also available at this course homepage. This is this every week homework. You need to watch 2 SIGGRAPH or the CVPR video. Basically, I don't expect you to go over all the paper, but just watch the SIGGRAPH Asia paper or the CVPR video, and then basically basically summarize their abstract. Basically, here abstract is your summary. You should not copy the abstract of the paper of the paper. You need to actually summarize that video, and basically talk about what the main content of the video, and submit at the beginning of every beginning of every Tuesday, Monday class. And then if you go to the KLMS, if you go to the course homepage, there actually the paper or video summary submission site. So submit it online before the Monday class. Sorry about not the Tuesday, Monday class. And then basically there's just 1 paragraph should be okay. You can use the English or Korean. Yeah, you don't need to write down long summary. Okay, that's the today lecture material. Next time I'll talk about ray tracing and radiosity, which are the 2 main building blocks for the rendering. Also, the next time probably we will have we'll get together at the class. Thanks so much. See you next time. Bye.